Namaste to all. Today we are going to solve problems based on thermal properties of matter. So in last class we solved up to 11.10. In today's class we are going to solve next problem, that is 11.11. So what they ask the question is, the coefficient of volume expansion of glycerin is 49 into 10 to the power of minus 5. What is the fractional change in its density for 30 degree Celsius rise in temperature? ಅಂತ question ಕೇಳಿದಾರೆ. So here, let us see how to solve this one. 11.11 it is. So ಏನು ಕೊಟ್ಟಿದ್ದಾರ? From the question, coefficient of volume expansion of glycerin is represented by alpha into V. So then that value is given, that is 49 into 10 to the power of minus 5 per Kelvin ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So next ಏನು ಕೊಟ್ಟಿದ್ದಾರ? Rise in temperature. So that value delta T ಅಂತ ತಗೊಂತೀವಿ, that is given 30 degree Celsius ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Fractional change in volume. So ಅದನ್ನ delta V by V ಅಂತ represent ಮಾಡ್ತೀವಿ. So next, change is related with change in temperature, that is given by the formula. So delta V by V is equal to alpha V into delta T. So delta V by V ಅಂದ್ರೆ ಏನು ಬರಿಬಹುದು? V, difference in temperature, V2 minus of V into T1 is equal to, so alpha V into delta T is kept as it is. So this is V into T1 into alpha V into delta T ಅಂತ ಬರಿಬಹುದಾ? So ಇದನ್ನ ಯಾವ ತರ ಬರಿಬಹುದು? So m divided by rho into T2 minus of m divided by rho into T1 is equal to m divided by rho into T1 into alpha V into delta T. ಆ ರಿಲೇಷನ್ ಹೆಂಗ್ ಬಂತು ಅನ್ನೋದಕ್ಕ ಇದನ್ನ ಬರಿತೀನಿ. m ಅಂದ್ರೆ ಮಾಸ್ ಆಫ್ ದ ಗ್ಲಿಸರಿನ್ ಇಲ್ಲಿ. So m is nothing but mass of glycerin. Alpha T1 ಅಂತಂದ್ರೇನು? Sorry, rho ada. So that is not alpha, rho it is. Rho into T1. Idu enidu? That is nothing but initial density. Initial density at temperature T1 iddaga. ಅದೇ ತರ rho into T2 ಅಂದ್ರೆ final density at temperature T2 ಇದ್ದಾಗ. Final density at temperature T2 ಇದ್ದಾಗ. So ಅದನ್ನೇ ಹೆಂಗ್ ಬರಿತೀನಿ? So difference ಅನ್ನ density rho into T1 minus of rho into T2 divided by rho into T2 ಅಂತ ಬರಿಬಹುದಾ? That's equal to alpha in V into delta T. So ಇಲ್ಲಿ alpha, so ಇದನ್ನ whole thing ಏನಂತ ಬರಿಬಹುದು ನಾವು? So this is nothing but fractional change in density ಅಂತ ಕರಿತೀವಿ. So therefore, the fractional change in density of glycerin is calculated by that is given by 49 into 10 to the power of minus 5 into 30 ಅಂತ ಮಾಡ್ತೀವಿ. So ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 1.47 into 10 to the power of -2 ಬರುತ್ತಾ. So this is the solution for 11.11. So what they have given, ಅವ್ರು ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತಂದ್ರೆ ಅಲ್ಫಾ ವಿ ಕೊಟ್ಟಿದ್ದಾರೆ ಕ್ವಶನ್ ಅಲ್ಲಿ 49 into 10 to the power of -5 per Kelvin. Rise in temperature delta T 30 degree Celsius ಕೊಟ್ಟಾರ. Fractional change in volume ಅನ್ನು delta V by V ಅಂತ represent ಮಾಡ್ತೀವಿ. So change is related with the temperature is given by the formula alpha V by V is equal to alpha V into delta T ಅಂತ ಬರ್ತೀವಿ. So ಅದು ಹೆಂಗ್ ಬಂತು ಅನ್ನೋದಕ್ಕೆ ಇದನ್ನೆಲ್ಲ ಬಿಡಿಸಿ ಬರ್ದಿದ್ದೀನಿ. So here rho into T1 minus of rho into T2 divided by rho into T2, that is also written as alpha V into delta T. ಅಲ್ಲಿ ಇದನ್ನ whole thing na fractional change in density ಅಂತ ತಗೋತೀವಿ. Fractional change in density of glycerin is calculated by 49 into 10 to the power of -5 into 30 ಮಾಡಿದಾಗ, so fractional change in density of glycerin we got 1.47 into 10 to the power of -2. So this is the solution for 11.11 it is. So next we shall see next problem. So that is 11.12. 11.12 ಏನ್ ಕೇಳಿದಾರೆ ನೋಡ್ರಿ. A 10 kilowatt drilling machine is used to drill a bore in a small aluminum block of mass 8 kg. How much is the rising temperature of the block in 2.5 minutes? Assuming 50% of the power is used in heating the machine itself or lost to the surroundings. Specific heat of aluminum. Avre question alli kottidare. So first question ಅಲ್ಲಿ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡ್ರಿ, from that try to write the given thing. So question ಅಲ್ಲಿ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು, so in the question itself what they have given is, so they have given 10 kilowatt drilling machine is we are using to drill a bore in a small aluminum block of mass 8 kg. So how much is the rise in temperature of the block in 2.5 minutes, assuming 50% of power is used up in heating the machine itself, lost to the surrounding. Specific heat of aluminum they have given that is 0.91 joules per grams per Kelvin anta kottidara. So from the question try to write the given things what they have given. So note from the question what they have given, power of the drilling machine anna P anta ತಗೊಳ್ಳೋಣ. ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ಅದನ್ನ 10 ಕಿಲೋವ್ಯಾಟ್ ಅಂತ ಕೊಟ್ಟಾರ. ಅದನ್ನ ನಾನು ಯಾವ ತರ ಬರಿಬಹುದು, 10 into ಕಿಲೋ ಅಂದ್ರೆ 10 to the power of 3 ವ್ಯಾಟ್ ಅಂತ ಬರಿಬಹುದು. ಪವರ್ ಅನ್ನ ವ್ಯಾಟ್ ಒಳಗೆ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. ಮಾಸ್ ಆಫ್ ದ ಅಲ್ಯೂಮಿನಿಯಂ ಬ್ಲಾಕ್ ಕೊಟ್ಟಿದ್ದಾರೆ, m is equal to 8 kg ಅಂತ ಕೊಟ್ಟಾರ. ಅದನ್ನ kg ಅಂದ್ರೆ 10 to the power of 3 ಅಂತ ಬರಿಬಹುದಾ, ಗ್ರಾಮ್ಸ್ ಆಸ್ ಇಟ್ ಇಸ್ ಬರ್ದೀನಿ. ಟೈಮ್ ಫಾರ್ ವಿಚ್ ಮಷೀನ್ ಈಸ್ ಯೂಸ್ಡ್, ಟೈಮ್ ಎಷ್ಟು ಕೊಟ್ಟಾರ, ಮಷೀನ್ ಯೂಸ್ ಮಾಡಿರುವಂತ ಟೈಮ್ 2.5 ಮಿನಿಟ್ಸ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಮಿನಿಟ್ 1 ಮಿನಿಟ್ ಅಂದ್ರೆ 60 ಸೆಕೆಂಡ್, ಅದನ್ನ ಇಂಟು ಮಾಡಿದ್ರೆ 150 ಸೆಕೆಂಡ್ಸ್ ಬರುತ್ತೆ. ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಆಫ್ ಅಲ್ಯೂಮಿನಿಯಂ ಅನ್ನ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಸಿ ಅಂತ ತಗೊಳ್ಳೋಣ. ಸ್ಪೆಸಿಫಿಕ್ heat of aluminum ಅನ್ನ C ಅಂತ represent ಮಾಡೋಣ. 0.91 joules per grams per Kelvin ಅಂತ question ಅಲ್ಲೇ ಕೊಟ್ಟಿದ್ದಾರೆ. So rise in temperature of the block after drilling. So let us consider that one as delta into T. ಚೇಂಜ್ ಇನ್ ಟೆಂಪರೇಚರ್ ಅಂತಾರ ತಗೋಬಹುದು. ಹಂಗಂದ್ರ ನೆಕ್ಸ್ಟ್ ಟೋಟಲ್ ಎನರ್ಜಿ ಆಫ್ ದ ಡ್ರಿಲ್ಲಿಂಗ್ ಮಷಿನ್ ಎಷ್ಟ್ ಆಗತ್ ನೋಡನ್ಮ. ಟೋಟಲ್ ಎನರ್ಜಿ ಆಫ್ ಡ್ರಿಲ್ಲಿಂಗ್ ಮಷಿನ್ ಅನ್ನ P ಇಂಟು T ಅಂತ ತಗೊಳ್ಳೋಣ. ಸೊ ಇದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರ ಪವರ್ ಅವ್ರು ಕೊಟ್ಟಾರ 10 ಇಂಟು 10⁻³ ಟೈಮ್ 150 ಸೆಕೆಂಡ್ಸ್ ಅಂತ ನಾವೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿವಿ. ಇದನ್ನ ಮಾಡಿದಾಗ 1.5 ಇಂಟು 10⁻6 ಜೋಲ್ಸ್ ಅಂತ ಬಂತು. ಆಮೇಲೆ ಕ್ವಶನ್ ಅಲ್ಲಿ ಏನ್ ಕೊಟ್ಟಿದಾರ, ಗಿವನ್ ಏನ 50% ಆಫ್ ಪವರ್ ಈಸ್ ಯೂಸ್ಫುಲ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಕ್ವಶನ್ ಅಲ್ಲಿ. ಇದನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಸೊ ಯೂಸ್ಫುಲ್ ಎನರ್ಜಿ that is calculated by using formula 50 divided by 100 into 1.5 into 10⁻6 ಅಂತ ಮಾಡಿದಾಗ ಆಫ್ಟರ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ we got 7.5 into 10⁻5 joules ಅಂತ ಬರುತ್ತೆ. So we know delta Q is given by mc into delta T. So here from this substitute all the known values, or we want to calculate delta T, known terms are kept one side and unknown terms or whatever we want to calculate that is kept on another side. Therefore from this we are modifying this formula like this, delta Q E divided by m into C. Substitute the value 7.5 into 10⁻5 divided by 8 into 10⁻³ into 0.91. After simplification, we are getting 103 degrees Celsius. Therefore, in 2.5 minutes of drilling, rising temperature of the block is 103 degree that is degree Celsius. So, so from the given, from the question, read the question and try to write the given things, what they have given. So they have given that is power of the drilling machine, they have given P is equal to 10 kilowatt they have given. So kilo under 10⁻³ ಅಂತ ಬರಿಬಹುದು. Mass they have given 8 kg, kg ಅಂದ್ರೆ 10⁻³ ಅದನ್ನ ಗ್ರಾಮಿಗೆ ಬರ್ದಿದ್ದೀವಿ. Time used by machine 2.5 minutes ಆಯ್ತು. 1 minute or 60 seconds ಇರ್ತಾವ, multiplied by 60 ಮಾಡಿದಾಗ 150 seconds ಬಂತು. Specific heat of aluminum they have given 0.91 joules per grams per Kelvin. Rising temperature of the block after drilling anna let us consider delta into T. So from this, so total energy of drilling machine is calculated by using formula P into T. Substitute all the given values and calculate total energy of the drilling machine. In the question itself, they have given 50% of the power is useful adre. So useful energy is calculated by using formula delta Q is equal to, substitute all the given values. 50% is used. Therefore, 50 divided by 100 into 1.5 power into 10⁻6 ಮಾಡಿದಾಗ useful energy we got that is 7.5 into 10⁻5 joules ಬಂತು. So then we want to calculate change in temperature. So our rise in temperature of the block after drilling. So that is represented by delta T is equal to delta Q whole divided by m into C. Substitute all the values. Delta Q value is 7.5 into 10⁻5. Mass is 8 into 10⁻3 and the specific heat for aluminum is 0.91. Another C is nothing but specific heat of aluminum value. In the question itself they have given, and after simplification we got delta T value is 103 degrees Celsius bantu. So this is the solution for 11.2 it is. So next one 11.13. So in question 11.13 is copper block of mass 2.5 kg is heated in a furnace at a temperature of 500 degrees Celsius and then placed on a large ice block. What is the maximum amount of ice that can melt? And question specific heat of copper kottara ಆಮೇಲೆ heat of fusion of water ಕೊಟ್ಟಿದಾರ. So let us see how to solve this one. So from the question what they have given, so they have given mass of the copper block kottara m is equal to 2.5 kg ಅಂತ ಕೊಟ್ಟಾರ. The mass of copper block. So ಅದನ್ನ ಗ್ರಾಮಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರ 2500 grams ಬರುತ್ತೆ. Rise in temperature of the copper block ಅನ್ನ delta T ಅಂತ ತಗೊಳ್ಳೋಣ. So that is 500 degree Celsius. Specific heat of copper ಕೊಟ್ಟಿದಾರ 0.39 joules per grams per degree Celsius. ಆಮೇಲೆ heat of fusion of water ಅನ್ನ L ಅಂತ ಕೊಟ್ಟಿದಾರ 335 joules per grams ಕೊಟ್ಟಿದ್ದಾರೆ. ನಾವೇನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಮ್ಯಾಕ್ಸಿಮಮ್ heat the copper block lose is, that is calculated by using formula Q is equal to M into specific heat into delta T. So delta T is nothing but rising temperature of the copper block. So substitute all the values. So mass is 2500, specific heat is 0.39 into delta T value is 500 degrees Celsius. After substituting all those, we got 4,87,500 joules anta barutta. So that is maximum heat the copper block can lose. So next ಏನ್ ಮಾಡ್ತೀವಿ? Let us consider, let M1 be the amount of ice that melt. ಯಾವಾಗ? When copper block is placed on ice block. ಆವಾಗ ಏನಾಗುತ್ತೆ? Heat is gained. ಆವಾಗ heat gained by the melting ice is calculated by heat gained by melted ice is given by the formula Q is equal to M1 into L ಅಂತ ಮಾಡ್ತೀವಿ. So ನಮಗೇನ್ ಬೇಕು? M1 value ಬೇಕು. So M1 is equal to, just modify the formula. Q value we calculated, that is 4,87,500 divided by L value is 335. ಎಲ್ಲ simplify ಮಾಡಿದ್ರ 1455.22 grams ಬಂತು. ಇದನ್ನ kg convert ಮಾಡಿದ್ರ 1.45 kg. The maximum amount of ice that can be melt ಎಷ್ಟು ಬಂತು? 1.45 kg ಬಂತು. You can convert or keep in that in terms of grams ಒಳಗಾದ್ರೂ ಇರ್ಬೋದು, kg ಒಳಗಾದ್ರೂ ಇರ್ಬೋದು. So heat gained by melted ice is calculated by using formula Q is equal to M1 into L. ನಮ್ಗೆ M1 ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ನೋನ್ ಕ್ವಾಂಟಿಟೀಸ್ ಒನ್ ಸೈಡ್ ಇಡ್ರಿ, ಅನ್ನೋನ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅನ್ನ ಒನ್ ಸೈಡ್ ಇಟ್ಟು. ಸೊ M1 ವ್ಯಾಲ್ಯೂ ಆಫ್ಟರ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ವಿ ಗಾಟ್ ದಟ್ ಒನ್ ಆಸ್ 1455.22 grams, or ಅದನ್ನ kg ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 1.45 kg ಅಂತ ಬಂತು. ಸೊ ದಿಸ್ ಇಸ್ ದ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ 11.13 it is. Next we shall see 11.14. ಏನ್ ಕೇಳಿದಾರ ಅವ್ರ ಕ್ವಶನ್? 11.14 ಅಲ್ಲಿ they ask the question, in an experiment on the specific heat of metal, it 0.20 kg block of metal at 150 degrees Celsius is dropped in a copper calorimeter. So in the question itself they have given water equivalent is 0.025 kg containing 150 centimeter cube of water at 27 degrees Celsius. The final temperature is 40 degrees Celsius. Compute the specific heat of the metal and care. If heat loses the surroundings are negligible, if your answer is greater or smaller than the actual value of the specific heat of the metal and care. Let us see how to solve this one. So from the question what they have given, so from the question ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು mass of the metal ಕೊಟ್ಟಿದ್ದಾರೆ. So mass of the metal they have given that is m is equal to 0.20 kg ಕೊಟ್ಟಾರ, ಗ್ರಾಮ್ಸ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 200 grams ಅಂತ ಬಂತು. Initial temperature of the metal T1 is equal to 150 degrees Celsius. ಆಮೇಲೆ ಫೈನಲ್ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಮೆಟಲ್ T2 ಅಂತ ತಗೊಳ್ಳೋಣ. T2 is equal to 40 degrees Celsius ಕೊಟ್ಟಾರ. Calorimeter has a water equivalent of mass m is equal to 0.025 kg, or if you convert into grams 25 grams ಅಂತ. ಇದೇನಿದು? If you don't know you can write this is calorimeter has water equivalent mass. Next ಏನು ಕೊಟ್ಟಾರ? ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ವಾಟರ್ ಅನ್ನ V is equal to 150 centimeter cube. Mass of water at a temperature T is equal to 27 degrees Celsius. ಅವಾಗ ಏನಾಗುತ್ತಾ 150 into 1 ಮಾಡಿದಾಗ 150 grams ಬರುತ್ತೆ. ಫಾಲ್ ಇನ್ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಮೆಟಲ್ ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಸೊ ಏನ್ ಮಾಡ್ತೀರಿ? fall in temperature of metal. So that is calculated by delta T is equal to T1 minus of T2 ಮಾಡಿದಾಗ 150 minus of 40 ಮಾಡಿದ್ರೆ 110 degree Celsius ಅಂತ ಬರುತ್ತೆ. Specific heat of water is equal to 4.186 joules per gram per Kelvin per degree Kelvin. And next ಏನು ಕೊಟ್ರ? specific heat of metal ಅನ್ನ let us consider C. C ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. ನೆಕ್ಸ್ಟ್ heat loss by the metal that is given by the formula theta is equal to m into specific into change in temperature. Let us consider that one as equation 1. So rise in temperature of the water and calorimeter is given by ಅದನ್ನ ಏನ್ ಮಾಡ್ಕೊಳ್ಳೋಣ? ಡೆಲ್ಟಾ ಥೀಟಾ ಡಬಲ್ ಡ್ಯಾಶ್ ಅಂತ ತಗೊಳ್ಳೋಣ. ಸೊ ದ್ಯಾಟ್ಸ್ ಈಕ್ವಲ್ ಟು m1 ಇಂಟು ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಆಫ್ ವಾಟರ್ ಇಂಟು ಚೇಂಜ್ ಇನ್ ಟೆಂಪರೇಚರ್, ಅದನ್ನ ಟಿ ಡ್ಯಾಶ್ ಅಂತ ತಗೊಳ್ಳೋಣ. ಇದನ್ನ ಹೆಂಗ್ ಬರಿಬಹುದು? ಕ್ಯಾಪಿಟಲ್ M ಪ್ಲಸ್ ಸ್ಮಾಲ್ m ಡ್ಯಾಶ್ ಇಂಟು ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಆಫ್ ವಾಟರ್ ಆಸ್ ಇಟ್ ಈಸ್ ಇಟ್ಟಿನಿ ಡೆಲ್ಟಾ ಟಿ ಡ್ಯಾಶ್. ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದಿಸ್ ಒನ್ ಆಸ್ ಇಕ್ವೇಷನ್ 2. ಸೊ ಇದನ್ನ ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀನಿ? heat lost by metal is equal to heat gained by water and calorimeter. ಇದನ್ನ ಹೆಂಗ್ ಬರೀತೀರಿ? ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ ಮಾಸ್ ಇಂಟು ಸ್ಪೆಸಿಫಿಕ್ ಇಂಟು ಚೇಂಜಿಂಗ್ ಟೆಂಪರೇಚರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಗೇನ್ ಬೈ ವಾಟರ್ ಅಂಡ್ ಕ್ಯಾಲೋರಿಮೀಟರ್ ನ m ಪ್ಲಸ್ ಆಫ್ m ಡ್ಯಾಶ್ ಇಂಟು ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಆಫ್ ವಾಟರ್ ಇಂಟು ಚೇಂಜಿಂಗ್ ಟೆಂಪರೇಚರ್ ಡ್ಯಾಶ್ ಅಂತ ಎಲ್ಲಾ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ರಿ ನೋನ್ ಇದ್ದಿದ್ದು and unknown ಇದ್ದದನ್ನ as it is ಇಡ್ರಿ is equal to capital M value 150 small m dash under 25 into specific heat of water is 4.186 into delta T dash value 39. ನಮಗೇನ್ ಬೇಕು ಈಗ C value ಬೇಕು. So C value is kept one side and all the known values are brought to one side. ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ಮೇಲೆ ಏನ್ ಬರ್ತೈತೆ ನೋಡ್ರಿ. After simplification, we are getting 0.43 joules per gram per Kelvin barata. So if some heat is lost to the surrounding, then value of C will be smaller than the actual value. So this is the solution for 11.14. ಏನ್ ಕೊಟ್ಟೈತಿ? Mass value ಕೊಟ್ಟಾರ, T1 ಕೊಟ್ಟಾರ, T2 ಕೊಟ್ಟಾರ, ಆಮೇಲೆ calorimeter has a water equivalent mass they have given. Volume ಕೊಟ್ಟಿದ್ದಾರೆ 150 centimeter cube. ಆಮೇಲೆ fall in temperature of the metal calculate ಮಾಡ್ತೀವಿ. Change in specific heat of water ಕೊಟ್ಟಿದ್ದಾರೆ. So heat lost by the metal, a specific heat of metal, and let us consider C. Heat lost by the metal is calculated by using formula theta is equal to m into specific heat into delta T. Let us consider that one as equation 1. Next, rise in temperature of water and calorimeter is calculated by using formula delta T double dash is equal to m1 specific heat of water into change in temperature dash. So then let us consider equation 2. Heat lost by metal is equal to heat gained by water and calorimeter. So we want to calculate the value of that C. C is nothing but specific heat of metal and now find out ಮಾಡಕತ್ತೀವಿ. So all the known values are kept one side, unknown values are kept on another side. So specific heat of metal value we got 0.43 joules per grams per Kelvin ಅಂತ ಬಂತು. So this is the solution for 11.14 it is. Next we shall move to next question. So 11.15. So that is very easy. So they have given some data. So what they have given 11.15 given below observation moral specific heat at room temperature of common gases. They have given from that the measured molar specific heat of these gases measured molar specific heat of these gases are marked different from those for monoatomic gases typically. Molar specific heat of monoatomic gas is 2.92 calorie per mole per Kelvin. Explain this difference. What can you infer from the somewhat larger than the rest value of the chlorine and the kedara? So some values they are already given. Allowed. How to solve this one? The gases listed in the given table are diatomic adavavu. So beside the translation degree of freedom, they have other degrees of freedom under mode of motion. So heat must be supplied to increase the temperature of the gases. So this increase the average energy of all mode of motion. Hence, molar specific heat of diatomic gas is more than that of monatomic gas. So if only rotation mode of motion is considered, then molar specific heat of diatomic is given by the formula. ಯಾವ ತರ ಕೊಡ್ತೀವಿ ಅದನ್ನ? So that is given by the formula. If only rotational mode of motion is consider ಮಾಡಿದ್ವಿ ಅಂದ್ರ ಅವಾಗ molar specific heat of diatomic molecule gas is given by 5/2 into R. ಇದನ್ನೇ ಯೂಸ್ ಮಾಡ್ಕೊಡ್ರಿ 5/2 as it is ಇಟ್ರಿ R ವ್ಯಾಲ್ಯೂ ನ 1.98 in substitution ಮಾಡಿದ್ರೆ we are getting 4.95 calorie per mole per Kelvin ಬರುತ್ತೆ. So with the expectation of chlorine, all the observation in the given table agree with this 5/2 R. So this is because at room temperature, chlorine also has a vibration mode of motion besides rotational and translation mode of the motion. So this is the solution for 11.15. And 11.16, that is based on theory concept. Go through it yourself. 11.6 and 11.7. And next we shall solve 11.18. ಏನ್ ಕೇಳಿದಾರ ನೋಡ್ರಿ 11.18. So what the question is, so 11.18 is a brass boiler has a base area of 0.15 meter square and thickness 1 centimeter. It boils water at the rate of 6 kg per minute when placed on a gas stove. Estimate the temperature of the part of the flame in contact with the boiler. Thermal conductivity of brass value they are already given. Heat of vaporization of water they are already given. From the given data, let us see how to solve this one. So 11.18 from the question, what they have given, initial temperature of the body of the child they have given T1 is equal to 101 degree Fahrenheit. Final temperature of the body of the child and the T2 anta ತಗೊಳ್ಳೋಣ. So that is 98 degree Fahrenheit. Change in temperature and the delta T is equal to 101 minus of 98 into 5 by 9. ಯಾಕೆ ಹೇಳ್ರಿ ಇದು Fahrenheit ಐತಿ, degree Celsius convert ಮಾಡ್ತೀವಿ. So time taken to reduce the temperature T is equal to 20 minutes ಐತಿ. Mass of the child M is equal to that is 30 kg they have given. Adhan grams convert madre 30 into 10 to the power of 3 grams anta barutte. Specific heat of human body is equal to specific heat of human body. So that is equal to specific heat of water. So let us consider adana C anta ತಗೊಳ್ಳೋಣ. So ಅದನ್ನ ಎಷ್ಟು ಕೊಟ್ಟಾರ 1000 calorie per kg per degree Celsius anta ತಗೊಳ್ಳೋಣ. So from by using this given data, so latent heat of vaporization of water value ಕೊಟ್ಟಿದ್ದಾರೆ. L is equal to 580 calorie per grams ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So ನಾವೇನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು, heat lost by child is given by delta theta is equal to M into specific heat into change in temperature. So substitute all the known values. 30 into specific heat is 1000 into change in temperature 101 minus of 98 into 5 by 9. ಯಾಕಂದ್ರೆ Fahrenheit ಒಳಗೆ ಐತದ. So after simplification, we got this one as 50,000 calorie bantu. So let M1 be the mass of water evaporated from the child's body in 20 minutes ಅಂತ ತಗೊಳ್ಳೋಣ. Let child's body in 20 minutes. Then ಅವಾಗ ಏನಾಗುತ್ತಾ loss of heat through water is given by the formula delta T is equal to M1 into L. So we want to calculate M1 value. M1 is equal to delta theta divided by L. Delta theta value is 50,000 divided by 580 ಮಾಡಿದಾಗ. So we are getting 86.2 grams ಬಂತು. So next average rate of extra evaporation caused by drug is given by M1 divided by T. So that T is calculated by 86.2 divided by 200. ಅವಾಗ ಎಷ್ಟು ಬರುತ್ತಾ 4.3 grams per minute. That is the average rate of extra evaporation caused by drug. So 11.1. So by using given data, so we wrote the given things. By using all those, we calculated heat lost by the child. That is given by the formula delta theta is equal to mass into specific into change in temperature. And then M1 be the mass of water evaporated from child in 20 minutes. So then loss of heat through water is calculated by using formula delta theta is equal to M1 into L. And by using that M1 value, average rate of extra evaporation caused by drug is calculated by using formula M1 divided by T. So after simplification, we got that one as 4.3 grams per minute it is. So next we shall see next one. That is 11.20. So 11.19 we have to solve. So explain why in that 3 questions they asked. So 11.21, 11.22, those are theory concept it looks like. So try to answer yourself those for those questions. Next we shall see 11.20. So next we shall see next question. A thermocol ice box. A thermocol ice box is a cheap and an efficient method of storing small quantities of cooked food in summer. In particular, a cubical ice box of size 30 centimeter has a thickness of 5 centimeter. If 4 kg of ice is put in the box, estimate the amount of ice remaining after 6 hours. Like that they asked. The outside temperature is 45 degrees Celsius and efficient of thermal conductivity of thermocol is 0.01 joules per second per minute per Kelvin. Heat of fusion of water is 335 into 10 to the power of 3 joules per kg. So let us see how to solve this one. So in the textbook it is 11.17. Please check the number there. So what they have given, side of the cubical ice box they have given, that is S is equal to 30 centimeter. If we convert into meter, it becomes 0.3 meter. And thickness of the ice box L is equal to 5 centimeter. If we convert into meter, it becomes 0.05 meter. Mass of ice kept in the ice box M is equal to 4 kg and time gap T is equal to 6 hours. 6 into 16 minutes, 60 seconds it is. So outside temperature, let us consider T is equal to 45 degrees Celsius. Coefficient of thermal conductivity of thermocol, let us consider K is equal to 0.01 joules per second per minute per Kelvin. Heat of fusion of water, we are considering L is equal to 335 into 10 to the power of 3 joules per kg. In the question itself they have given. So let M be the total mass of the ice that melt in 6 hours. So M be the total amount of ice that melt in 6 hours. So therefore, amount of heat lost by food is given by theta is equal to Ka in the bracket T minus of 0 into T divided by L, where A is the surface area of the box. So that is given by A is equal to 6S square, surface area of the box 6 into S square, 6 into S value is 0.3 whole square. So after simplification, we got the surface area of the box is 0.54 meter cube. And here, this theta, we are going to calculate K value substituted as 0.01, A value is 0.54, and T value is 45, and this is 0, and the small t value is 6 into 60 in 60 minutes 60 seconds divided by L value is 0.05. So after simplification, we got 1,49,000. Sorry, 1,04,976 joules. But we know theta is equal to m dash into L. So we want to calculate m dash. So therefore theta divided by L. Substitute all the known values. So after simplification, we are getting 0.313 kg. So mass of ice left left is calculated by 4 minus of 0.313 is equal to 3.687 kg we are getting, and hence amount of ice remaining after 6 hours is 3.687 kg we are getting. So this is the solution. So next we shall see 11.18. A brass boiler has a base area 0.15 meters square and thickness 1 centimeter. It boils water at the rate of 6 kg per minute when placed on the gas stove. Estimate the temperature of the part of the flame in contact with the boiler. Thermal conductivity of brass they have given. Heat of vaporization of water also they have given. So let us see how to solve this 11.18. So first what they have given, brass area of the boiler they have given, that is A is equal to 0.15 meter square. Thickness of the boiler they have given L is equal to 1 centimeter. If you convert into meter, it becomes 0.01 meter. Boiling rate of water, let us consider R is equal to 6 kg per minute. And mass they have given, that is 6 kg, and time is 1 minute. 1 minute is nothing but 60 seconds. And thermal conductivity of brass, that is K is equal to 109 joules per second per minute per Kelvin. It is heat of vaporization, L value is 2256 into 10 to the power of 3 joules per kg, and amount of heat flowing into water through brass base of the boiler is given by the formula theta is equal to Ka in the bracket T1 minus of T2 into small t divided by L. T1 means temperature of the flame in contact with boiler. T2 is the boiling point of water, that is 100 degrees centigrade. And then heat required for boiling the water, that is given by theta is equal to m into L. Let us consider this one as equation 2. And here, let us consider this first one as equation 1. Equating equation 1 and 2. So what it become? M into L is equal to Ka in the bracket T1 minus of T2 into small t divided by L it is. Substitute all the values. 6 into 2256 into 10 to the power of 3 into 0.01 divided by 109 into 0.15 into 60. So after simplification we got, so this one ML. So from this we are modifying this one. So before substituting these values, so here ML, so we want difference of temperature. So this is modified as T1 minus of T2 is equal to ML small l divided by Ka into T. Just this formula is modified and substitute all the given values, and after simplification we are getting this one as 6 into 2256 into 10 to the power of 3 into 0.01 divided by 109 into 0.15 into 60. So after simplification, we got 137.98 degrees Celsius. The temperature of the part of the flame in contact with the boiler is 237.98 degree Celsius. So this is the solution for 180. So try to practice these problems. And if you are having any doubt based on this, just put in the chat box.